wear a wig.
Even that.
Yeah, 15. Yeah.
Oh, yeah.
Days spent on those bad boys. Days. One-liners.
Online assist.
Oh, yeah.
This test is pretty 30.
Incredible things.
Just incredible.
Oh, Professor, what about those proofs that the rational root, 2 is not a rational root? Are you familiar with that one?
You mean the 2 is not a rational number? You mean the
Root? Yes. Okay.
Yes.
Because we were trying to figure that out, and
Yeah.
so some professor blew us off.
Yeah, Professor Johnson blew us off, but my uncle came to me with that one,
He was trying to say that the proof was that square root of 2 is rational. Square root of 2 is equal to A over B, and you sub in A equals 2A.
You know?
Yes, did you see it?
Well, we didn't really understand it, but
we couldn't figure out why
my uncle told me about it, and I wanted to figure it out. Yeah.
No, it was square root of 2 is irrational, right?
Yeah, there's a theorem that proves that the square root of 2 is irrational. Yeah.
It's very easy. It's very direct. A lot of times in mathematics, I want to prove something that's difficult to prove. I just give up. And I assume it's not true. And if I can come up with a logical contradiction, it proves it's true. It's called a proof by contradiction. Did you guys catch my words? Sometimes to prove a statement's true, I assume it's false. And if that leads to a logical contradiction, that means my original assumption that the statement's false is incorrect, and it must be a true statement. I mean, if I just assume the square root of 2 is rational, suppose root 2 is a rational number, doesn't that just mean there exists 2 integers p and q? Such that the square root of 2 is equal to the ratio of those 2 integers? I mean, if it really is rational. And you guys, just without loss of generality, can we assume that this fraction p over q is completely reduced? You know, I can always do that because no matter what the fraction is, I can always reduce it. So let's just assume in the end that whatever the fraction is, I went through the process of actually reducing the fraction. So everybody, check this out. If I've got this equation as a true statement, I'll clear fractions. I'll multiply both sides by q. I'll square both sides. Now I want a yes or no answer. Does that necessarily imply that 2 divides evenly into the left-hand side? Or I'll rephrase the question. Yes or no? Does 2 divide evenly into the left-hand side?
Yes.
Yeah, it's
Sure,
going to have to.
Factor 2.
Yeah.
But that necessarily implies, though, that 2 is going to divide evenly into the right-hand side.
No.
What do you mean, no? Oh, I know, but you don't know what p is. And certainly if these two things are equal to each other, and there's a factor 2 on the left-hand side, there's got to be a factor 2 somewhere on the right-hand side.
Yes.
No tricks. No, think about it.
Oh, yeah, that makes
They're
sense.
equal to each other.
Yes.
And if 2 divides evenly on the left-hand side, it's got to divide evenly into the right-hand side because they're equal to each other. No tricks.
Okay, so then you end up with p squared over 2.
Yeah, I won't write it as a fraction, though. I'll just talk about divisibility. But you know, p is an integer. It's being squared. So if 2 divides evenly into square, then necessarily 2 divides evenly into p itself. You know what? That's so important. Can I circle that in red? Oh.
No.
I can't circle in red. How about a different Christmas color? Oh, a little better. But you guys, if 2 divides evenly into p, then I think on the right-hand side, that implies that 4 is going to divide evenly into p squared. So, since 4 divides evenly into the right-hand side, I think 4 divides evenly into the left-hand side. But this necessarily implies...
Isn't that 2q squared?
Oh, I'm so sorry. Is the wrong symbol? Is that a q squared on the left-hand side?
Yeah.
Yes.
squared. So 4 divides evenly into the left-hand side, which I wrote incorrectly. But this necessarily implies that 2 divides evenly into 2q squared. Actually, I misspoke. That means 2 divides evenly into the single q squared. But if q is an integer, and it's being squared, then that necessarily implies 2 divides evenly into q itself. Oh shoot, hold it, look inside the circle. I was assuming that my fraction is completely reduced, and now all of a sudden I see that 2 divides evenly into p and 2 divides evenly into q, which contradicts the fact that p over q is reduced. This contradicts. I can spell contradicts, I really can. Contradicts.
Can you make the R an N?
That,
Or the B an N?
that p over q is reduced. Therefore, my original assumption that the root 2 was rational is incorrect, so root 2 must not be rational. I proved what I wanted to show.
So if you actually plugged root 2 into a calculator, is it an irrational number?
Well, a calculator will never be able to understand that.
Because
the calculator isn't going to go out indefinitely and find there's no repetition.
yeah, because when I plugged it into Python, which Python just goes on forever, I actually got an end to it, to root 2. And I don't know if that's just a problem
Then
with
the
the
computer
program.
made a mistake.
The computer made a mistake? All right.
Never trust a snake to do your math.
Yeah, a computer will never be able to go up. A computer will never be able to understand that that's a rational number because it's a finite process machine.
Is there an end to that number?
No.
No?
You can guess that it's going to be irrational.
You heard about the Greeks and the square root 2?
No.
Really?
Yep.
You told us.
Oh, did
Our
I?
art class.
I don't know. I've never heard this.
You've heard of the Pythagorean society?
No.
No.
Really?
Gosh.
The Pythagorean society was one of the first groups in science and mathematics in ancient Greece that took the time to prove everything that was known at that point. It was led by Pythagoras, who was an absolute 100% nutcase. You gotta read how he died. It's just ridiculous.
That's how you die? Yeah, tell us.
There's mixed company in here. I feel too embarrassed.
Come on.
But anyway, one day the member of the society was messing around after the group already proved a lot of parents with the assumption that every number is rational. One of the members messed around one day with a square, a side length of 1, and found the length of the diagonal to be the square root of 2. Not that they use this notation. They didn't understand rationality and irrationality. They just said, they would say this number is, they found it not to be commensurable, meaning it can't be reduced to smaller numbers. This guy was really excited. He went back to Pythagoras and said, look, there are some numbers that are not rational. And he just kind of looked at him and thought, well, we can either admit to the entire world community or that we were wrong in our assumptions, or shut this guy up. So he tied him up, put him on a boat, sent him out to the Mediterranean, and dumped him off, so nobody would find out. What's interesting is when the rest of the Greeks really found out, see, math can be dangerous. When the rest of the Greeks found this out, they were so upset. They said, this doesn't make any sense. The entire Greek culture halted any study of arithmetic or algebra. That's why when high school geometry, all of it was works of Greeks, they got so pissed off at this. They said, this doesn't make any sense. Well, how can a number not be rational? And they gave up completely. And you read that 13-volume section of books called Euclid's Elements. There's a mention of only 2 types of angles, and he does not use numbers for them. 13 whole books. Sorry, I'll stop. Yes?
Can we hear how Pythagoras died?
No. Pythagoras believed everything in life could be explained mathematically. Religion, how you live, everything. And Pythagoras had this really nutty idea that beans were in the shape of a part of a male human body. And so you can never step on a bean. Yeah, and the community got so upset when they finally say, we had it with this guy. They came into his house with what do you call those things, torches, and they burned the house down. And they chased him out to kill him. But they were chasing him, and he had quite a lead, and he ran into a field of beans. So he had to stop, and they caught up to him and killed him. Anyway, you guys, this really isn't going to work. I'm sorry, can I just take 30 seconds and grab some decent pens? Just 30 seconds.
David's fault.
Nope. Somebody couldn't write.
Timing this.
20.
Yeah, I'm gonna stop by Walmart on the way home and just buy a bunch of pens.
I have some pens already.
Yeah. It seems like a lot of old mathematicians were killed for being smart.
Or for being stupid.
They killed Socrates too.
How did he die?
Socrates? It's something that had to do with religion. Like he was, he believed that, religion wasn't really kind of solid at that time, and it didn't explain everything, and so they killed him because he was,
Thanks,
not
guys.
religious enough. I don't know. I'd have to like look it up.
So, you guys want to talk applications?
Yeah.
I just can't see.
Kill the lights here.
I'm sorry, I'm old. So there's a boat in the ocean. It's 4 miles from the nearest point on a straight shoreline, and that point is 6 miles from a restaurant. I don't know if you can see this building here. And the woman plans to row a boat straight to a point on the shore and then walk along the shore to the restaurant. Here's the point. So, first things first. If she walks at 3 miles per hour and rows at 2 miles per hour, then at which point on the shore should she land to minimize the total travel time? I guess where should I start? No,
Asking why she's so far away from the shore. And why is she rowing 4 miles out?
Can we start with distance equals rate times time and then get that in terms of
in terms of what?
put time equal?
I think it's perfect. So what you're really saying is you're identifying what we're trying to maximize, minimize, which really is time. I think that's the key. And so I think the total time to make this trip could be interpreted as, I don't know, the sum of the amount of time it takes to row with the amount of time it takes to swim. Excuse me, not swim, but walk. Excuse me. You guys, I'm probably showing too much on the board. You don't have to put all this garbage in there. I'm just in front of the entire classroom. I'm trying to show you what I'm putting on the board. Now, I gotta confess, when it comes to the swimming business and the walking business, she's walking and swimming at constant speeds. So I do think I have a mathematical legal right to interpret the amount of time it takes for her to row to be nothing more than a ratio of the distance for which she rowed with the rate at which she rowed. I'll increase that by the amount of time it takes to walk. That too could be interpreted as a ratio for which she walked a distance to the rate at which she walked that distance. Please stop me if I'm being unclear. And I think when it comes to these two rates, you know what, you guys? I'm going to stop. I can put them in right now, can't I? The rate at which she rows is 2 miles per hour, but the rate at which she walks is 3 miles per hour. I just got to take a break and look at the time values.
I would
Yes, what would you do?
identify the distance between that point and that point as a value of x maybe, and then the distance
From here to here is going to be.
well, that's gonna be 6 minus x.
Can you guys help me with this distance in case I need it?
Well, that's 4 square root of 4 squared plus 6 squared.
Do you guys agree? 4 squared plus.
Oh,
X
sorry,
squared.
X squared.
Do you guys agree with everything in the picture so far?
Yes.
I mean, that's just coming from the Pythagorean theorem. And that being the case, I think we're done. Because I think in my picture, the distance for which she rows that boat is going to be nothing more than the square root of x squared plus 16. And I think that the distance for which she's going to take a walk on the shoreline is going to be 6 minus x. You guys, look what we've just accomplished. We created a function for time t in one variable. Now I can apply my basic tools of calculus. I can differentiate, find critical numbers, and see if those critical numbers yield local extrema.
Sorry, I
That's
just
okay.
didn't understand. When you took the derivative of it, how come we ended up with dr over r?
You didn't take the derivative.
Yeah, I haven't differentiated yet. Okay, would you at least agree with this? I mean, if you're traveling at a constant rate, is it not true that distance equals rate times time?
Okay,
So time can be interpreted as a ratio of distance to rate.
alright.
And I was just using subscripts to remind myself I'm dealing with rowing as opposed to walking.
Oh,
That's all I did. That was just distance over rate. Yeah, I might be using too goofy a notation. You guys might have to stop. I said too much already with critical numbers. How can you answer this question? What ways can you answer this question?
Common denominator and then.
No, you're telling me what to perform algebraically,
Oh.
and I agree with that. I'm just saying, now that I've got my t function, what are my choices?
Well, simplify it and then differentiate and find where the derivative equals 0.
And then what?
And then
Solve for
test them.
Test them with the first derivative test.
Yeah.
So I think Nabil's saying, differentiate, find all critical numbers, build a number line, test to see if you change an increase and decrease, or vice versa, see if you've got a little extrema. A second technique is to find critical numbers and do not build a number line, but compute the second derivative function and use the second derivative test. A third alternative is to use neither, and simply look at t evaluated as extreme endpoints, like 0 and 6, and evaluate any critical number in between, because that's how you and I find absolute extrema. Only because this function is defined over a closed interval. Which one of these three techniques do you have to use?
Second one.
Okay, if you want me to use the second derivative test, I gotta come in and at least use the first derivative, or excuse me, find the first derivative function first. Sorry, too many firsts. And I think that gives me
Two.
1/2 or 1/2.
x over.
It sounds like it's dying. Square. It's 2 root.
X squared plus
Ooh,
16.
that was painful. And then, what?
You don't wanna simplify it first?
Simplify what?
Like you could put it into one fraction and just use the, quotient rule.
Oh, sounds nasty. Quotient. I think it'd be a lot of work.
Okay.
Anyway, what did you get for the second term? Now you're gun shy.
Well,
It would just be
2x.
it would be -1/3.
Thank you.
Yeah.
And next, let's you and I find critical numbers. Actually, you guys, aren't we finished with the critical numbers? I yield none downstairs, but I do yield one upstairs. And so I think when x is equal to 0, t prime of x is equal to, oh, excuse me, I misspoke, didn't I?
Yeah.
My apologies, I forgot this constant term here, I was just looking at that. I guess I'm not done. I think t prime of x is equal to 0 simply when this entire first derivative function is equal to 0. But that means that x over 2 root x squared plus 16 is equal to 1/3. I'll clear fractions. I'll square both sides. I'll subtract 4x squared from both sides. I'll both divide both sides by 5 and extract roots, and I think that gives me 8 over root 5. Actually, I made a mistake. It should be plus or minus 8 over root 5. It's just that I'm dealing with distances. I know it's going to be a positive value.
How come 6? Oh, never mind.
You sure?
Distributed the 4.
I did. I distributed the foreign. And so that's my one critical number. Actually, Nabil, do you mind if I don't do it your way? I don't actually use the second derivative test. When I take a peek at the first derivative function, it's just too much work to compute the second derivative. And since it's too much work, I probably would have just said, either go with a absolute extrema technique, or build a sign graph and test on either side of this critical number. Let's give it a shot. If x is equal to 0, isn't this first derivative function clearly negative 1/3? It's negative. However, if x is as big as, I don't know, how about something as big as 6? This is a 36, there's a 40. That's 3 over root 40. Yeah, I can't do it.
0.474.
Say it again.
0.474.
Oh, thank you. So it's positive. That means my t function, the original time function, changes from decreasing to increasing. you know what? I blew it. I really did. I've done so much work on the board, I really forgot what the question is. So question, we're unsure should land in order to minimize the total travel time? Well, clearly, when x is equal to 8 over root 5, she might not want to tell it to her employer, she might want to put it in the calculator. But that's the value of x for which the amount of time is minimized. Someone said no.
Sorry, I was thinking the other way around, maximized.
Oh, gotcha. And if I'm trying to maximize time, what do you do?
We would take the extreme out of it.
Yeah, you know it's going to be what the either left endpoint or the right endpoint. Plug 0 in for x, plug 6 in for x, and see if the time function is the biggest for one of those two values. One of those two is going to give you the answer. You guys okay with that?
Wouldn't the answer be phrased differently than that?
What do you mean? You know
Like
what?
if
Maybe
did
you're right in the
6
view.
minus 8 over at 5 miles away from the whatever.
To the restaurant.
Restaurant.
Or you could have said, imagine her going directly to the shore. From there, you need to walk over this direction a distance of 6 over root 5 miles. I guess you can word it that way. Yeah, you'd want to be careful with the wording. But I'm okay with that.
And it's to maximize time, is that right?
Minimize.
No, we're minimizing time, and that was the question.
Oh, I think that's.
He just added a new question. I'll say, well, if I want to maximize time, then what should I do? He doesn't want to get to work. So.
Makes sense.
So how would you write that differently if you did want to maximize it?
If I want to maximize time, clearly core of the sine graph is going to occur at the left extreme value for x, which is 0, or the right extreme value, which is 6.
Okay.
So I would have done, Bradley, is I would have taken the original function, this function right here. Let's test it. Let's evaluate it here, and let's evaluate it here, and see what we get.
Would be 0 over 0. 0 plus 0.
Wouldn't it be 4? Am I wrong? If I plug 0 for x, root 16 is 4.
Oh,
4 divided by 2 is
yes.
2, sorry. And I plug 0 in here, I get another 2. 2 plus 2 is 4. But I think t evaluated 6 is, yikes.
Got it.
36.
I'm on it. It's on it.
You're on it. All right, I'll give up.
6
Squared
Square root of 80.
plus 16 over 2. Ooh. 2 plus.
It's root 13.
Oh, because that's 0. Okay. That doesn't matter. 0. You get root 13, and that's going to be 3.61.
What's the answer?
3.6. Oh, 4. 0.
What's the answer? No, make a full sentence.
To maximize the amount of time.
Yes.
straight to.
She'll go swim straight to the shore, perpendicularly, and then walk the rest of the distance. If she really doesn't want to get to work at the restaurant,
Are you gonna do B or?
if you'd like me to. What's part B? No, before I do part B, is that okay?
So how do you know what the endpoints are going to be? Like, with this problem, you can see that you're working with the one side of this triangle that's formed, but like, you're dealing
See,
with...
I think you're looking in the wrong place. You're looking over here. I think you should be looking over here. I think it's just because the sine graph is the first derivative function. I think clearly I'm going to max out at the left extreme or right extreme or whatever x can be. I think it's
How do you know
because...
what x could be?
Now come back to the picture. Because x represents this distance right here, the biggest it could be is 6 miles, meaning she swims the whole length. The smallest x could be is 0, which means she rows this length and then walks the rest.
But, I mean, optimization problems can take any number of forms, and...
No, that's true. As a matter of
X
fact,
value may not be as clear as this.
you know, you're completely right. If over that realistic interval from 0 to 6, I increase, decrease, and change the law.
So, I mean, the real question is how do you know what your interval is with just any problem for optimization?
I can't give you an answer. It all depends on how you define the independent variable. In this case, that would be x. Because of how I defined x as being the length of this triangle, I think just because of picture, it's clear that x is going to range from 0 to 6, including those endpoints. And that's why I'm saying you didn't even have to use the first or second derivative test to answer this question. You could have just used your technique for finding absolute extremum.
If you are looking at that, there really would be no way to actually find the maximum distance because she could just go off in the other direction as far as she wanted on the water and go as far
You know,
away
that's
from
true.
there.
I just think with the way the question was phrased, it's understood that she's never going to row in this direction over here.
Okay.
I think in the context of the problem, that was understood.
Okay.
But you're right, if she really doesn't show up to work for years, she could just swim in the opposite direction.
Yeah.
I'll just take the ferry in.
So you guys, if she walks at a rate of 3 miles per hour, what's the minimum speed at which she must row so that the quickest way to the restaurant is now directly with no walking?
Well, that two would go away, and you would have a variable there. Because you're not given that anymore. They said, oops, we take that back.
Shouldn't it just be 6 squared, or the root of 6 squared plus 4 squared?
What about it?
Well, that's where she is to the restaurant directly. I don't even understand why it gives her walking speed, because it's asking you what her speed would be if she rose directly there, so she's not walking essentially.
We have no, how does she got the row at, to be faster than what you want.
Okay, so it's
Well, then, so rate
6 squared plus 4 squared.
Well, the formula is still this. Not, I see. Six minus x.
What would you guys say about this critical number? If it really were the case that the minimum distance, the minimum time could be when she just rose directly, what would x have to be if rowing the entire distance really is the answer to the question?
6.
Yeah, I agree. I think this critical number right here would have to be 6. So that in my picture, that brings this value right here all the way over to 6, so that I'm continually decreasing with my time function, which means I minimize time at that right endpoint. So I think now coming back, let's see, how fast does she walk? She's walking at a speed of 2 miles, or 2 miles per hour?
3 miles.
I'm sorry, I misspoke. What was the speed at which she was rowing? It was 2?
2.
It was 2?
It
Yeah.
was.
It's
No,
nothing
but
now.
now we don't know. Call it R. And now you're going to take this whole process all the way through and go backwards, force x to be equal to 6, and find out what the corresponding R value is.
So you made x6, distributed it from the endpoint to the actual minimum?
Yes, so that the minimum time would just be that value right here.
That's a time, that's not okay.
Well, this is a value of x for which will minimize the time for which she takes this trip. Are you guys there?
So you said the 6 equals the derivative function?
No, I'm just saying, now is your responsibility to try to find the value of R that actually gives you a critical number of positive 6.
So you work it from both ways? That's what you're saying?
Yeah. Somewhat an awkward question, but you can do it. Only because of time constraints. You guys think I can move on?
Yes.
So I've lost it. What's next on the very far board?
21.
21.
It took us like 45 minutes. I wonder if one.
Did it really?
Yeah,
What's the question?
this is kind of
Cone
lengthy
is
one.
constructed by cutting a sector of an angle theta from a certain sheet of metal with a certain radius. And the cut sheet is then folded up and welded. What angle theta maximizes the volume of the cone? Well, how do you compute the volume of a cone?
1/3 pi r squared h.
Nice. And so I'm going to try to maximize the volume of the cone, but if I'm going to do this, you guys, I want to be able to express the volume as a function in theta.
Split that mess up into a rectangle.
Um,
To cut a section of it so you can go use the Pythagorean theorem to find your h.
Do you mean a rectangle? I'm not sure what you mean.
I'm saying take a cross section of that,
Of the cone?
of the cone, and you'll have a rectangle. You feel?
Yeah.
Go down, go down.
Well, you need a triangle?
Yeah, just write it
I
as
got you.
Well,
I can't see a rectangle in
oh,
here.
oh, one of those geometric
One
things.
of those geometric things.
Yeah, one of those geometric things.
those shapy things that we learned.
The shapy things.
So how's that gonna help?
20 is going to be your
Hypotenuse.
Thank you.
I'm just helping out with the vocabulary.
And R is going to be your radius, little r. And then your,
Oh, you mean up top?
Yeah, you're gonna need 2 R's.
because your R, big R is going to be your big one.
Yeah.
Big
Big R is gonna be equal to 20,
Oh,
But-
you mean over here, gotcha,
but
gotcha.
the hypotenuse is also equal to big R, so we could just call big R both.
Isn't this radius just gonna be 20 period?
Well, yeah, that'll be 20 period, but so will big R.
And you're saying big R is over here?
Big R is the 20 over
Yes.
on that side.
Like that?
Yes.
Yeah.
Okay, I'm just not sure why you're calling it big R. I mean, it's
Because it's a radius, so we already have another radius, so we got a little r and a big R, so we can.
Gotcha.
Yeah.
Well, wasn't that just
Oh, height.
What about the height?
Write it in.
You wanna call it H, you wanna call it
Yeah, H.
You wanna call it H? How does that help them?
H squared plus R squared equals 20. Solve for H, and you have your H variable to plug in.
Well,
So you're saying
h
over
squared
here.
plus r squared equals 20 squared.
Well, yeah, 20 squared, thank you.
Do you wanna write everything in terms of R's or H's?
It was easier for us to solve with R's.
Well, I think it'd be easier to write everything in terms of H's over here. Maybe solve for R over there, because I think when you solve for R, you're gonna get that R is equal to, is the square root of 400 minus 8 squared.
Oh, I see what
R is equal to the square root of 400 minus 8 squared, but when I square that R, oh, nice, no radicals. I just get a 400 minus 8 squared. It's just easy to differentiate. Now that I've got the volume being equal to pi thirds times a 400h minus h cubed, we can differentiate because now I got volume as a function of one variable. And v prime ends up being nothing more than a pi thirds times a 400 minus 3h squared. And I think my volume derivative function has a critical number right at, yikes, is that a 20 over root 3? Now I can test on either side of it, but if I test it on an h value of say, I don't know, 20, then I think this thing right here is going to be negative. But if I choose a value of h like 0, I think the whole derivative function is going to be positive. So I see a change in increase and a decrease in the original volume function when h equals that value. Therefore, the h value is going to yield a local max for the volume. Actually, it's going to be the absolute max in this particular example. But that doesn't answer our question. I thought he asked for what angle theta maximizes the volume of the cone. How do you find theta?
Relate the surface.
Did you write the surface area?
What about the surface area?
Well,
You get the area of the circle.
so it's gonna be
Did you find the area of the circle minus the area of the sector?
So in this particular case, you're saying the area of the entire sheet? I think when it comes to the area of the entire sheet, it's just going to be the area of the circle minus the area of the circular sector. But that means the area, the total area is going to be, is that a pi?
pi
times
r
20
squared.
Is that a 20?
Yeah, pi. Yeah.
Minus 1/2 times my radius squared times the central angle theta. And so I think the surface area is nothing more than 400 pi minus is that a 200 theta?
Yes.
Assume my arithmetic is correct, you guys.
Yes.
Oh shoot, that doesn't help. Yes.
Is that going to equal the surface area of the?
And how would you compute the surface area of the cone?
Pi r.
Pi r.
Like the 20, the 20, I guess.
Well, what's the formula for the surface area of the cone?
Pi r s plus pi r squared.
No, we found the volume. So it's pi r.
S is the
express the surface area in terms of R's and H's? Anybody?
I little r capital R.
You mean this?
Yes.
Where'd you get that?
From 20 being the side, I is 360 times the radius.
So you're doing this. You're saying it's pi times big R times little r.
Yes.
Yeah.
Well, and then if there's a bottom, you add the bottom value to that, but there's no bottom there.
You know, I was assuming not.
Yeah,
Is that gonna help?
yeah.
How?
Because you can solve for. Oh, I forgot what I did. Oh.
So number one, you stuck into 20 for big R.
Oh, see, because the reason it helped us was because we solved for r on this side.
Oh, you know what? That's what you said. So actually, your life would be a little easier, yeah, because you already found this critical number in terms of R. I didn't do it. So I think what I have to do next is go back. I mean, if this is I've lost it. H value, to find the corresponding little r value, I'm just going to redraw the triangle. And to redraw that nifty black triangle, here's an R, here's a 20, but I forget what my H value was.
20 over root 3.
So I think in this particular scenario, to find the value for R, I'm sorry for your nice writing, using the Pythagorean theorem, doesn't it just give me the square root of 400 minus 400 over 3? Or shall I say the square root of 2 times 400 over 3? Or shall I say just a 20 root 2/3? So, that would be my corresponding R value related to the H value I found as my critical number. But I'm too far away. What is it?
20
20
times.
times root 2/3?
Yes.
Oh shoot, you guys, do I have too many variables in this equation?
No.
Of course not. It's only one variable, theta. Solve for theta, you're done. That'll answer the question.
Yep.
Are you there? How
After
about you-
hours.
I apologize. How about 25? But it was great mental exercise. It was
So-
a good workout.
So what should we memorize for the tests in regards to geometric formulas?
You know, not a lot. I expect you guys to know the basics like maybe the volume of a right circular cylinder, because if you don't know it off the top of your head, you can easily draw a picture and figure it out. Volumes of rectangular solid, area formulas for trapezoids, triangles, squares, rectangles. Trapezoids? Trapezoid? You don't know what a trapezoid is?
Well, I know what a trapezoid is. I just don't remember the area of it off the top of my head.
Oh, you don't have to.
You can derive it.
It's
You
just-
can figure that out pretty easily.
You just put this up in two triangles. Here's one base, here's the second base, here's the height. Isn't the area of the bottom one 1/2 of base 2 times height times h? The top one is 1/2 of base 1 times h. So when I add those together, I just think I get 1/2
Memorize that.
sum of the bases times
That'd be
h.
good.
Can we have this on the test?
No. Sorry. You know, you need to